Okay, one thing that's going to become very helpful in answering these questions is if we have the unit circle values memorized. And so I'm going to start by just writing out this table of my unit circle values. And so I know I'm going to have the angles pi over 6, pi over 4, and pi over 3. And then I'm going to have sine theta, cosine theta, and tangent theta. Now, sine theta is an increasing function, so I'm going to have 1/2 square root of 2 over 2 and square root of 3 over 2. Cosine is the cofunction of sine and therefore is going to have the same values, just in reverse order. And then finally, tangent, remember, is sine over cosine. And so therefore, just take 1 divided by the square root of 3. That's going to give you square root of 3 over 3. Root 2 over root 2 is going to be 1, and root 3 over 1 will give you root 3. Okay, that's going to be real helpful in figuring out what these answers are, but in addition to that, what's going to be helpful is knowing the points on the unit circle. And so for quadrantal angles, that's what I'm talking about here, quadrantal angles, we know that we have the point here of 1, 0, the point here of 0, -1, the point here of -1, 0, and the point here of 0, -1, and we know that x is equal to the cosine of theta, and that y is equal to the sine of theta. And so looking now, with all of that information, at this first example, we have cosine inverse of 0. Now, 0 is the trig value. So it's the trig function value, meaning we're looking for where do we see 0 located. Well, if you look here, I don't see 0 anywhere here. 0 is not here. And so therefore, we're not going to use this in order to answer this question. What we're going to use now is this down here, and we're looking for when does the cosine equal to 0. Well, cosine is the x-coordinate, and so the x-coordinate is 0 at pi over 2 and at 3 pi over 2. But it cannot be both answers, or otherwise it would not be a function. And so what that means is that we have to remember the range restrictions on cosine inverse, which is going to be 0 to pi. And so which of those two answers is between 0 and pi? And that would be pi over 2. And so pi over 2 is going to be the answer here because cosine of pi over 2 is equal to 0, and pi over 2 is on the range of inverse cosine. Okay, here on example B, we have sine inverse of 0, and so I'm looking around to see where I see 0 as a value on sine, and I notice that up here I don't have 0, but down here I am going to have 0, because if I think about y equals sine theta, I need the y value to be 0. So that would happen here at the angle 0 or here at the angle pi. However, remember that there is a restriction on the range of sine inverse. It's from -pi over 2 until pi over 2. The answer to this question has to be somewhere in that range. And so 0 and pi are the possibilities, but the only answer is going to be 0 because 0 is on the appropriate range. And so you've got to be careful to remember these range restrictions on these functions. Okay, here on letter C, don't be deceived here by 1 over the square root of 2. This is just another way of saying arc sine of square root of 2 over 2. And so because of rationalizing, so if I were to take 1 over the square root of 2 and multiply by square root of 2 over 2, then that would give me square root of 2 divided by 2. And so we're looking for which angle has a sine value that is equal to square root of 2 over 2. And so taking a look at my list of values here, I see square root of 2 is here, and the angle that produces that particular trig value is pi over 4. And so that is going to be the answer to this particular problem. Okay, for arctangent of 1, again, we're looking to see which angle has a tangent that is equal to 1. And so here for tangent, I see 1 right here, and that's going to be the angle pi over 4. And so sometimes it's very easy. It's just a matter of knowing, do you know the unit circle values? And if you do, a lot of the times it will be easy, especially whenever the number right here is positive. It's whenever that number starts to be negative that things get to be a little confusing. So the positive values, remember, that's always going to come from quadrant 1, and quadrant 1 are these three angles right here. And so as long as you know this table, you're going to be able to answer any question that has inverse tangent of a positive number, because that's going to come from quadrant 1. Okay, here on letter E, we've got cosine inverse of 1/2, and so 1/2 is obviously a positive number, and so I know that this is going to come from quadrant 1, and so cosine equaling 1/2 happens at the angle pi over 3, and so the answer here is going to be pi over 3. Now, cosine inverse of a negative number, that is maybe the most missed type of problem here in section 4.7, so I want to work in E version 2 here with you, which is basically this same question, except I'm going to make the 1/2 negative. And now let's talk about this. Now, I'm still looking for what angle cosine is equal to negative 1/2, but I've got to keep in mind that the range for cosine inverse is from 0 to pi, and so that means that the answer to this is going to have to come from quadrant 2, and it's going to have the same reference angle that our answer into E1 had, which was pi over 3. So again, why was it pi over 3? Because cosine inverse of 1/2 means pi over 3. But I've got to have the angle in quadrant 2 that has a reference angle of pi over 3. And so it's helpful here to draw a picture. Put yourself an angle here in quadrant 2 and make that reference angle pi over 3. And then we need to figure out what this angle right here is. Well, the best way to do that is to remember that right here is pi, and so to get to that angle, I just need to go from pi and go backwards pi over 3. And so this is going to equal to pi minus pi over 3, which will equal to 3 pi over 3 minus 1 pi over 3, so that you can actually subtract those, and the final result would be 2 pi over 3. So notice that that angle is in quadrant 2, just like we needed it to be. It has a reference angle of pi over 3, and so therefore if you were to do cosine of 2 pi over 3, what you would get is negative 1/2. And finally, most importantly, the answer that we got is on the range from 0 to pi. Okay, here in F, we've got tangent inverse of negative square root of 3. And so what I know for a fact is that because this is tan inverse of a negative, the answer is going to have to come from quadrant 4, and it's going to have to be on the range, actually not including here is really what I should write, not including negative pi over 2 until 0. And so what I'm going to do here is I'm going to look at the value in the parentheses here, which is square root of 3, and I'm going to look for that value on my chart. And so I see here tangent of theta is equal to square root of 3 when theta is pi over 3. And so here I'm going to write pi over 3, but the fact that it's negative root 3 here inside the parentheses tells me that my answer needs to be negative, and so the answer here is going to be negative pi over 3. Now think about how much easier that was than E2 on the previous slide, cosine inverse of negative 1/2. That's where we had to take pi and subtract the reference angle to get it to be in quadrant 2. Here for tangent inverse, you don't have to do that. You just have to get the answer to be in quadrant 4, and the easiest way to do that is just to make the answer negative. And not only is it the easy way, but it's the correct way, because that's what puts it on the correct range. Okay, similar story here on G. We've got arc sine of negative square root of 3 over 2. And so the first thing I notice is that this is arc sine of a negative. I know that that means it has to come from quadrant 4, and it has to be negative. So I'm just going to go ahead and put my negative there, because I automatically know that that is going to be a part of the answer. Now, which angle has a sine value of square root of 3 over 2? Well, here's sine, here's square root of 3 over 2, and that's the angle pi over 3. And so your answer here is going to be negative pi over 3. Okay, letter H is another opportunity for us to practice arc cosine of negative. And so the fact that this is arc cosine of negative tells me that the answer is going to have to come from quadrant 2. And let's try to see if we can figure out what the reference angle needs to be. Cosine root 3 over 2, well, if you go here, that's going to be pi over 6. And so the reference angle that we need is pi over 6. Now, draw a picture in order to help you here. Put your angle in quadrant 2, which is we know where it has to be, is quadrant 2. The reference angle is going to be pi over 6. And so to figure out what this angle is, we're going to start at pi and go backwards pi over 6. And so that's going to end up being pi minus pi over 6, which will be 6 pi over 6 minus 1 pi over 6, for a total answer of 5 pi over 6. So again, make sure that that answer for cosine, arc cosine, is always going to be a positive answer. No matter if what's on the inside is positive or negative, the answer is always going to be positive because the range is from 0 to pi, and that only includes positive numbers. And so make sure that you're never writing down a negative answer for arc cosine. Okay, in letter I, we have arc sine of negative 1/2, and so again here, since I know it's arc sine of a negative, I know that the answer is going to be negative because the answer's got to be between negative pi over 2 and 0, and then the reference angle I'm looking for is where sine is equal to 1/2, and so coming over here to the table, sine is 1/2 at pi over 6, and so therefore arc sine of negative 1/2 will equal to negative pi over 6. Okay, letter J here, we have another sort of easy one because remember, inverse trig of any positive value is always going to be in quadrant 1. And so one of these three angles up here at the top has got to be the answer. All you need to look for is where is sine, the square root of 3 over 2, and so that would be sine square root of 3 over 2, that would be pi over 3, and again it's positive because what's on the inside was positive. Okay, here letter K is a little bit of a trick question because it says arc sine of 2. But remember that when we talked earlier about sine inverse of x, the domain for sine inverse of x was negative 1 to 1. And so 2 is not in the domain of inverse sine, and therefore arc sine of 2 does not exist. If you were to type this into the calculator, you would get an error that said domain. And so because 2 is not on the domain from negative 1 to 1 of inverse sine of x, we say that it does not exist. Okay, finally we have example L here, arc cosine of the square root of 2 over 2. And so this is going to come from quadrant 1 because the input is positive, and so therefore we're just looking for the angle where the cosine is equal to square root of 2 over 2. So here's cosine, here's square root of 2 over 2, that's the angle pi over 4, and so that's going to be my answer to this question. Now I also want to work an example L2 with you, which would be arc cosine of negative square root of 2 over 2, and so I know that that is going to have to come from quadrant 2, and the reference angle is going to have to be pi over 4. And so again, I have to draw a picture here. It's a little more challenging than inverse sine and inverse tangent. The reference angle here is going to be pi over 4, and so to get this angle here, we're going to just subtract backwards from pi by pi over 4, and so pi minus pi over 4 will equal to 4 pi over 4 minus pi over 4, which is going to equal to 3 pi over 4.